Alright, so now that I've done a little bit of explaining of what alpha and beta errors are, what alpha levels mean, what's it mean to reject or accept a hypothesis, we're going to cover a couple of questions on good old Brainbuster 1 here. So, most of these questions are just trying to assess, do you understand the situations where we accept the null, where we reject the null, and what happens if we accept the null hypothesis but the differences are actually significant, or vice versa. So we're kind of trying to see if you've got a working knowledge of what the rules are for accepting and rejecting, as well as what are the different errors that we can commit. So we've covered most of this. One of the questions that seems to get people tripped up is, why is there a greater chance, this is number 6, of committing a beta error at 0.001 than at 0.05. Now if you go back to your chart and look, in fact I should probably pull it up, but if you look at an alpha level at 0.05 for a certain number of degrees of freedom, and then if you follow that across and you look at what happens to that critical T value as we decrease the alpha level, you'll see that that critical T value gets bigger and bigger. So what that means is that in order to reject the null, my calculated T value is going to have to be very, very big. So what happens as that alpha level gets smaller, like going from a 0.05 to a 0.001, my chances, or what I'm going to have to do is I'm going to have to accept the null. So when I accept the null hypothesis more often, I'm going to have more chance of committing a beta error. So your job for Brainbusters is to summarize that into a couple of sentences. All right, let's see, 7, 8, 9, those. I don't love these questions. It's not my style of question. It's more Gary's style. But what you're looking at, and don't get caught up on the numbers so much, get caught up on the rules for accepting and rejecting. I'll just give you a hint right here. He may give you a T value that's greater than the critical T and say something about accepting the null. You need to be able to see that and say, wait a minute, when the T value is greater than my critical, I reject the null. Got it? So don't get tripped up on that. And then finally, number 11, this one is crazy confusing, and its clinical application is minimal, so I'm just going to kind of tell you what it's all about. The question says, if our alpha level is 0.05 and the two-tailed critical value is 2.108, what would a T value have to be in order to have exactly 5% chance of committing an alpha error? Well, I know that an alpha error is when I reject the null when it's actually true. If my calculated T here was like 50, then there's no way I'm going to be committing an error. It's so much higher than the critical T that I know here that I can reject my null. The differences are significant. So the point here, the idea of this question is, the closer we get to that critical T value, the greater my chances are of committing this alpha error or rejecting the null when it's actually true. So to get to that point where we're exactly 5%, we need to be as close to that value of 2.108 as possible. If I were at 2.108, then I'm going to accept the null. So if I'm at 2.109, now I'm just enough above that critical value that I would reject it. However, I'm only a tiny little bit above, and so my chances of committing an alpha error there are going to be about 5%. So there's your answer to number 11. I hope that's cleared things up. Give this guy a shot. Turn in what you've got. If there's other questions or things, let me know, and I'll get back to you. I hope this helps.